Well, if you want to sing out,
Sing out. And if you want to be free, be free. 'Cause there's a million things to be. You know that there are.
and if you want to live high,
Live high.
and if you want to live low, live low. 'Cause there's a million ways to go. You know that there are.
You have to do what you want. All right, great song today, guys. I mean, if you haven't heard that song by Cat Stevens, that is a classic. So I would get out there and listen to the rest of that one. So today we're going to talk a little bit more about pizza. We're going to talk about arcs and their relationship to angles and circles. And then we're going to talk about how to find the length of an arc. So, like I said, we're going to briefly touch about pizza. We're going to talk a lot about pizza when we talk about circles, especially in our next lesson as well. So today, I just want to briefly touch about area of a circle. Okay, I'm sure you've seen this before in your previous class. To find the area of a circle, I do pi r squared. Oh my goodness, that's so bad. Pi radius squared. So pi r squared, where r equals our radius. Okay, now to find the, so I think of the, when I think about area, if I think about it in terms of pizza, I think about this as in terms of like cheese or the sauce. All right, area is the amount of something that you need to cover a specific, a specific spot. So if I think about the pizza, it's the amount of cheese need to cover the entire pizza, or amount of sauce need to cover the entire pizza. Okay, that's including the crust. Obviously, a lot of times we don't really include the crust. So when I say including the crust, it's not the crust. The crust is technically the outside edge of the circle right here. So when I think about the cheese or the sauce, it's the inside. It's the interior of the actual circle. Circumference is it's a perimeter of a circle. Okay, it's finding the perimeter of a circle. All right, so to find the perimeter of the circle, I do 2 pi r, or diameter times pi, where d equals diameter. All right, so I can do 2 times my radius. Well, 2 of my radii is equal to the whole diameter, or I can just, so in that case, I could just multiply my diameter times pi. So if I want to find the circumference here, the circumference, since ED is 10, ED is our diameter, our circumference would be 10 pi inches. Now, area is always units squared. Circumference is just regular units. Okay, circumference is imagining if I took my circle, I cut it like right here and made that line all straight. Okay, if I took the crust of the cheese or the crust of the pizza, ripped it and laid it out in a straight line, that's what the circumference is, the perimeter around your circle. Okay, so when I talk about circumference, I'm talking about crust. Area, I'm talking about cheese. All right, so let's talk about arcs. So arcs are a part of your circle. Arc consists of 2 points on a circle where all points on the circle need to connect the points to a single path. All right, so an arc is as if I'm talking about a pizza and I'm thinking about the crust of just my piece. All right, I just care about my piece, or the pizza that I'm eating. So like this right here is part of that. This is part of an entire circle. Okay, arc is just a chunk of a circle. All right, there's different types of arcs we'll talk about in a minute. A central angle is an angle whose vertex at the center of the circle. So here is our central angle. All right, our vertex, which is always denoted by our middle letter, has to be our center. Okay, that's how it's central angle. Central angles are related to their arcs in that central angles are congruent to arcs. So if this is 20, then the arc that it forms also has to be 20 degrees. All right, the arc that our central angles form have to be 20 degrees. So like I said, there's different types of arcs, right? There's a minor arc. A minor arc is one that is less than 180 degrees. Okay, it's less than 180 degrees. All right, so AB would be considered a minor arc of this circle. Okay, it says the central angle determines the minor arc again. So if this is 40 in here, then this is 40 out there. Or conversely, if the arc is 40, then the central angle is also 40. A major arc is the arc whose points are on the outside of the central angle. So if I think about this, all right, if I'm looking at this, this is my central angle here, okay? Here is the arc that it forms. Well, the major arc is this part of the circle, all right? Major arcs tend to be greater than 180 degrees, okay? Major arcs are just the rest. All right, minor means they're less, major means they're more. Okay, a semicircle is a specific type of arc. All right, I mean you should probably know what a semicircle is at this point, or you may have heard it before. Not probably, no, excuse me, but you may have heard about it this before. A semicircle is endpoints are the diameter. All right, so EF is considered our diameter. Well, a semicircle is half of a circle, so it's a 180-degree arc. Okay, this is half your circle, right there. Semicircle, semi-annually. If something occurs semi-annually and it's 2 times a year, well, a semicircle means half. All right, so here's another picture. Okay, a minor arc. So I'm going to name some minor arcs here. So any minor arcs, I could say AB. So to mark an arc, I put that little arch over the top. AB is a minor arc. XB is a minor arc. AX is debatable, so I'm not going to say it because I don't know where the center is. Major arcs. All right, major arcs. Most of the time, you're going to want to use 3 letters. So 3 letters to mark a major arc. So a good major arc would be AXB. This whole thing. Or XAB could be another major arc. All right. Semicircle, it's kind of hard to write on this picture because I don't know where the center of the circle is, so I'm not going to talk about a semicircle. Okay, so find the measure of each arc. Well, I want to find the measure of SQ. Okay, so I need to use what I have to find that. First of all, I'm going to tell you that O is the center of our circle. All right, O is the center here. Well, this little box right here, that means 90 degrees. And if my central angle is 90 degrees, then the arc has to be 90 degrees. Okay? If my central angle is 35, then the arc has to be 35. If O is the center of my circle, then this segment, P to R, since it starts on one side of the circle, goes through the center, and goes through another side like that, this is a diameter. Okay, P to R is our diameter. SO is considered a radius. SO cannot be considered a diameter because it starts on one endpoint and only goes to the center. It doesn't continue on to here. I cannot say SOQ is a diameter because, well, it's not one continuous line. It's 2 radii connected. Okay? So why did I say that this was a diameter? Well, that tells me that it divides my circle in half. Okay? So if it's half a circle, I know that this has to be 180 degrees. All right? So if this whole thing, so from P to Q to R is 180, and half of it is 90, well, then the other half also has to be 90 degrees. Okay? Meaning that Q to R right here is 90 degrees. All right, so if I want to find SQ, that's letter A says SQ. Well, SQ is going to be, okay, there we go. SQ is I'm going to go from S to Q. Here's my arc, SQ. SQ should equal 90 plus 35, which gives me 125 degrees. All right. RPQ. So I'm going R to P to Q. So I'm going to do that again. All right. I'm going to pause for a second and erase some of this stuff off here. Hopefully that's a little bit better. Okay. The order matters. So the order matters. RPQ. That means I go from R to PQ. Figure out how many degrees that is. Well, I can do it two ways. I can find out what the measure of this arc, SP, okay, by doing 180 minus 35. Or I can just take, since the minor arc is 90 degrees, major arc is going to be 360 minus that. Okay, so that's going to make this, oh my goodness, come on. Hold on. So that's going to give me an answer of 270 because I did 360 minus this little piece. Okay. I could have also done, like I said, SP is going to be 180 minus 35. So 145, and then just added it that way. P to R to S. All right. PRS. Pause again. Sorry about that. All right. So we're going from P to R to S. So again, the order matters. All right. So P to R to S, I can add up 90 plus 90 plus 35, or do 180, which is going to be 360 minus 145. I'm going to do 90 plus 90 plus 35 to get me to 15 degrees. All right. That is PRS. Okay. Here we go. Given diagrams, what can you say about A, B, and C, D? Well, they're congruent. They have the same measure. GH, what's the measure of GH? GH, well, if this is my central angle here, then GH is 35 degrees. Well, guess what? These types of circles, remember, those are concentric circles. EMF is also 35 degrees. So that makes this 35 degrees. So they're congruent as well. Okay. Can we develop a rule? We'll have two arcs. Have the same measure. Then they're congruent. All right. Arc. We already talked about arcs being made up of 2 points on a circle and everything in between. How many degrees are in a circle? We talked about that. There's 360 degrees. All right. Find the length of arc HG. Well, if I know if this is 60 and this is 8, what if I just wanted to find the distance all the way? Actually, you know what? I'm going to pause here. I'm going to do these last two problems on a different video, just because this arc length part is pretty important part of the lesson, and I don't want to cut it too short or be sped up. All right.